Hello everyone, today I am going to deliver a lecture on influence line of beam using Müller-Breslau's principle. First of all, I will giving the definition of live load and influence line. Then example, then provide the example of reaction of influence line of beam, example of shear influence line of beam, example of moment influence lines of beam, and then influence lines of uh, beam using Muller-Breslau's principle. Okay, let's start from the definition of live load and influence line. Here is the definition. We can see here. Not definition is some quotation is taken from Professor Dr. Anam Sir, University of Asia Pacific, Dhaka, Bangladesh. Live load, either moving or movable, produce varying effect in structure depending on location of the part of the consider of force function being considered, such as reaction. It could be shear, it could be moment, and the portion of the load producing the effect. Okay, so it is necessary to determine the critical position of loading system which produce the largest force, such as reaction, shear, bending moment, and to calculate that force after having found the critical condition. And then now we are going to the describe the influence line. An influence line is a diagram. So it is a diagram showing the variation of a particular force. What is force? Is a reaction, shear, and bending moment at a section stress at the position or other direction function due to unit load moving across the structure. Okay, influence line can be defined to be curved or ordinary, or of which may point equal the value of some particular function due to a unit load, say 1 unit load, and acting that on the point, and it is constructed by plotting directly under the point where unit load is placed, or ordinate height, which represent the value of particular function being studied when load is that is position. And an influence line is often useful to studying the effect of a system of moving load across a structure. Okay, let's start. Here is another example. Here is another, we can say, definition. Okay, influence line is a graphical representation that stress variation of reaction, shear force, and bending moment at a particular point due to application of unit load at any point of the structure. So you can see here the B point is a point of B. It is respecting the value is bearing respect with respect to the point of B. So you can see the influence is bearing. Okay, so here we can see the definition as come to that. So now we can see here the Müller-Breslau's principle. We can what we can say. Okay, we can also read the definition of we can example. So okay, now we'll see the influence line of beam using Breslau's principle. So now we'll see the Breslau's principle. That is also taken from Professor Dr. Anam Sir, University of Asia Pacific, Dhaka, Bangladesh. Influence line of beam using Breslau's principle. Although it is possible to derive the equation influence line using singularity function, so you can use singularity function. The method is still quite laboratories and so many mathematical to be used for practical purpose. So it is laboratories and mathematical use. Therefore, faster and less complicated method are desirable. So the Müller-Breslau's principle based on deflected shape. So we can say deflected shape of the molding structure is bearing use the method particular for dividing quantities influence line of the beam. So let's see the what is the Müller-Breslau loads principle. The ordinate of the influence line of any point, so you can any point, it could be shear reaction, shear bending moment of any structure are equal to those are deflected shape obtained by removing the restraint corresponding to that element from the structure and introducing in its place corresponding unit deformation into the modified structure. Therefore, a unit deflection of support is used for influence line of support reaction after removing the support. Unit discontinuity the section is used to um, influence line and it is shear after the inserting section shear cut, while unit rotation is used for influence line of bending moment after inserting an internal hinge. So we can see here two two type of three type of clue is been given. The support reaction after removing support. So if we calculate the support, then remove will be supporting will be removed. When we calculate the shear, then we are inserting section shear cut. We can cutting the shear, and we calculate the bending moment, then inserting the internal hinge. So we'll see when we'll use. So yeah, let's see the example of reaction of using this what this okay okay so here reaction influence, then I will draw the hinge support will divide the segment to segment from hinge support, not support to support, so we have to memorize. If support is allow the rotation, then that the support will be 0. uh, as usually ruler pin support is gives as 0. If there is a ruler pin support is there, then influence line will be inclined, and if there is a fixed support, then influence line will be horizontally straight line. Okay, so this is for reaction. Now we'll see the shear reinforcement. If uh, uh, where we will calculate the shear, then in that point we will insert a ruler support. Where we will calculate the shear, then the left support will be downward and right support will be upward. So like this, downward and upward. Okay, so we'll see. So when we will calculate a particular point, then we will imagine that is a segment. Then in that point to internal hinge and internal hinge to internal hinge, that we are considering a segment. This is the important for how we will calculate the segment. So firstly we will try if the segment is more fully upward or not, and secondly it will move, it is allow moving or not, and then moment influence uh, will inserting internal hinge where we will calculating the moment. Now we are trying to move the upward for hinge in the left side and right side. There is some exceptional cases. So let's see the reaction or influence. So what is the main theme? The main theme was uh, we will divide the hinge segment, not support to support. And what is the Müller-Breslau? Müller-Breslau have said that here the support reaction after removing the support. So we'll remove the support and put. Now we'll calculating the reaction RA. So we'll remove the reaction and putting upward 1 unit, and then we can see this will be go down. and if we calculate the reaction is B point, then we will calculate in upward in one unit 1, then it will be go down. Okay, so let's see another example here. If we calculate the reaction RA this point, then we can upward in one down, and these are there is no options. So point B, you can see if we uh, if we take in upward, then it will not like be that, but it will be like that. So these are not correct, I think, as there is a fixed support, so fixed orbit will not allow any rotation. Okay. uh, so 3, we can see here RA, so we can see RA, the it will be 1 unit 1 in upward, then it will be go down. And for B we will taking one unit 1, and it will the whole portion will be go to the upward, and then it will be go down, intersect the point. So we can see another example here. When we are calculating reaction A, so we are putting 1 unit 1 in upward, then it will go upward. After upward, it is go this way. So RC, we can see as usually C point, we are taking 1 unit 1, so it will be uh, so all the portion, this portion also try to go to upward, so that's why this portion is going to upward, and then this portion is go down to here, and melting as 0. Okay, so let's see another RD. So uh, if we uh, if we push in upward one direction, then it will be there, and after the then what will be happen. So if we say this segment, so after this down, then it will be this will be must be 0. So we can see uh, the member will be behave like that, and then will be there. So I have been seen here, the member will be like behave like that, then here. So we have to must be keep in mind that this is the reaction point, that's why it will be 0, must be 0. And we have been seen other reaction member is must be 0, other reaction member is must be 0. The support, in the support condition, that will be 0, we can see here. Okay, see, let's see another example. So this is the RA. So RA, if we push in one unit, so we are saying in the reaction will be 0, so this will be must be 0, we are saying here. So this portion will be upward and simultaneously, so it is go upward, and this will be 0, and it will be go down, and this will be 0. So we have been seeing there are two portion. If we memorize that, this support and this support will be 0, and the rest of portion we are melting here. So we can see here, if we upward in reaction C, this is the C point. Okay, so what will be happen? We can see if the support is trying to upward, then what will be happen? This segment and this segment. So this segment will be go down upward, and then it will be melting here, as the another support is will be must be 0. Okay, so we can see another RC. We can see here RC C point. If we push in upward, then it will be like that. This. So these are the basic theme, as we have been seen here. The support reaction after removing the support, so it will be using like this. But we have to remember that the every support will be 0. So this support will be 0 if will not here, as we are using RC, but not if we use RD, then RD. So this support will be 0, this support will be 0. How? This support and this support. And in this way, if we sing here, this support will be 0, and this support will be 0. Okay, so you can see this support and this portion is also 0. Okay, let's see another influence line, and we have been seeing influence line shear. So shear, how can we use the shear? This is the shear. After inserting a section cut, so we are cutting the section. So this is the, we are inserting cutting section, or we are using the ruler support. In upper portion we will take the upward, and lower portion we will take the bottom. So we are seeing here where we are using shear, like we are trying to calculate the shear. Then first of all we are we are inserting a ruler support in that point. Okay, we are using that point. And then where we'll try to calculate the influence line, in the left side will be go down. This is the left side will be go down. This is the left side will be go down, and the right side will be go upward. This is the right side will be go upward. Okay. um, so when we are taking the segment from this portion, and this portion will be segment, and uh, and let's try. There is a mathematical equation we have been seeing. This is the a divided by a plus a. This is the a, this is the b. So this means 3, and 3 divided by 3 plus 4. This is 0.424. uh, so if we calculate here, it will be b divided by a plus b, which will be 0.725. So if we deduct 1 minus 0.424, then it will be 0.71. Okay, so let's see how we'll calculate this. uh, okay, as we have been seen how we'll calculate the shear at BC, this point C. So at first we will inserting a ruler support here, and the left portion we are forcing in downward, and right portion we are pushing upward. So at the left portion we've been seeing this is the downward, so it will be here, and this will be 0, as we have been seeing this is the support. So in the support portion will be must be 0, and support portion will be 1, and the right portion we are taking in upward, so upward, and the support portion will be 0. You can see here another example. We have to calculate influence line at C. So this portion we have to calculate. So firstly we are inserting a ruler support. So and then we are calculating this left side. We are taking the downward. So we are pushing the downward, and right side we are pushing the upward. So we are pushing the outward, and it will be melting here as 0. We are known the support portion must be 0. Their support portion must be 0. So this portion will be 0. So this here, and we are melting here. So BD we are seeing we are using at T point as another. We have been known, if the two support is in staying in consequently at a time, then it will be fixed support, and there will be no deflection at all. So you have been seen there, here is that only right portion is upward, because there is no deflection is downside. We've been seen here another shear is C point. So this is the fixed support, that's why there is no deflection. We are using ruler support here. So if we push in downward, there is no deflection. In the right side, if we push in upward, then it will be behave like that. Shear, we can see here BE. We can see BE, that means this point. So we are using the ruler support here, and the left portion we are push on down, and we know the support portion will be 0. This support portion will be 0. So we are taking this portion and this portion. So as we know, this will be 0, this will be 0, and the right side this will be left. And how will be value? This is the A, this is the B. So A divided by A plus B is 0.60, and it will be 1 minus 602.4, or b plus a plus b will be 0.4. Okay, so we've been seen shear at b. So shear at d you can see here, as we are knowing, if two support are staying at position, that will be that will be react as a fish support. That's why there will be no deflection, and on the other hand you can see that this is the left portion only. So b, we can see here shear at b, where b, this is the b, at the point of at the point of the support. So we are taking here in bottom in downward. So this will be like this, behave will be like this, as this is the pin support, and this is the ruler support we have been seen here, and it will be like this. Okay, so another example we've been seen here, it might be we can see here BE. This is the E point we have been seen inserting inserting a ruler support, and go down in downward in the left side, and this is, we know this is the support, so it will be 0, and this is the support, it will be 0, and this is the support, it will be 0, and this is the support, it will be 0. Now we are uh, we are um, we are trying to it is go the downward. Then what will be happen? As we know, this will be 0, this will be 0, and this will be 0, this will be 0. We are calculating this portion. So this portion, this segment will be behave like this, as we know that this will be 0, and this will be like that. As we know this will be 0, then what will be happen in this segment. So this segment will behave like this, as this, and it will be like that. And so we've been seen here, so this portion is behave like this. So you have to think that where there is a support, then that point will be a cross at the 0. Okay, we can see here, find out RA, BT, BT, MC, MC. We can see the RA. So RA we are taking is upward, then it will be go down. As hence it will be also upward, then it will be behave like this. BCL, left side, we have been seeing left side. So we are if we trying here, and we are trying here, this the behavior like this. And BTR, we have been seeing the right portion, we are turning here, so behavior is like this. So BC, we have been seeing BC, so left portion is like this, and right portion is like this. MA, we are using a moment, as this is not moment portion, I will discuss laterally. And this is the RA, we have been seeing RA is the portion is RA, and this is the B point RC, and we are putting this point is 1 unit 1, and it will be like this. And this is the RE, we are using RE, as this is the support, this will be 0, and this is the support will be 0. So this is 0, and this is 0. So you are taking in upward one unit, then behavior like this way. And BB, we can see in here, BB here, you can see it will be like this. And BCL, which is left side, we have been seeing here, left side BCL, one left portion as behave like this. And BCR right, this is the BCR right portion, we are taking this here. So if you calculate here, and then the segment will be like this, and behavior like this, as the hinge support is here. And the right portion we have been seen, on the other hand, this portion will be reactor like that, as we are cutting here. We are cutting not at point C, it will be cutting at the right side, that's why this portion will be like this. And another one, if we see this segment, so what will be segment if we force in downward, that it will be behavior like this. Okay, that's why the behavior the segment is behavior like this. Okay, and we can see the another portion is upward, that's why it will goes upward. And BD we have been seen, and the similarly BD, here the point D we have been seen, uh, we're taking in at upward is there is no the fixed support, there is no deflection, and downward it been seen the behavior will be like this. And this portion will be must be 0, as we have been said again and again, this is the support and this is the support, that's why this portion will be it will be gone in 0 point. And MC and MU will say later how will calculate. So here is the MC, how will calculate the moment influence line of the statically determinate. Okay, how we'll get we can see the Müller-Breslau. Here is the thing, inserting internal hints. So we have been inserting internal hints. I have been saying where we will calculating the moment, then we are using the inserting internal hints. Then we can use this sign in left portion and this line as bottom portion. Okay, let's see here. We can see our we are calculating moment NC. So we are inserting internal hints here and pushing here in bottom side, left side, and pushing here in right side. So there that's why the arm or the segment will be behave like this, and another segment will behave like this. Is the internal hinge will be used because it is given here. It is saying in the principle of Müller-Breslau. You can see here another one C. So we are taking here. This is the exceptional, but we are not inserting. This is internal is inserting in the midpoint. When inserting moment, inserting a hinge at the point of support, then it will not go upward. Rather, it can diffuse in that position like this way. That's why this is the exceptional case. So we can see here this is the exceptional, as we've been seeing the fixed support is here, that's why the segment will be not occur, not what. Okay, we can see a moment ME. So this is the E. So we are using internal hinge here. So if we use internal hinge, then what I will say, this portion will be upward, as we are using this moment, this upward. And another portion we've been just saying for your little this point, as we are using internal hinge, that's why the segment is divided. So we are using this force, then it will be what will be happen, this it will be act like this. So it will be act like this, as is our internal, then it will go here. So we know the support will be must be 0, that's why it will be 0, and then it will be 0. So moment B, so this is the moment B, as we know this is the support, that's why the internal is does not go upward, as we have been using at a point of the support. That's why it will, rather than it is act in this way, so it will go down this way. Okay, let's see here. We have been seen here moment MA. So this is the point, and MA, this is the exceptional case we have been seen here. The force is acting here, and the force is acting here, it will be go down this way, and go to here, and go to here, MA. And what will be MC? This is the very easy. What will be, if we calculate the MC, then we are inserting here the internal hinge, then it will be we are acting a force here, so it will be like that. And another one, it will be like this. Okay, this is the MC. Okay, MC, another this portion we have been seeing in diagram MC. How we calculate MC? As we have been seeing, there is a hinge at the support, that's why the diagram, the support will be not upward, as it is staying at the support, so it will be, rather than it will focus in this this point and this point. So that's why we've been seeing MC. We are here. Sorry, it will be not work. So it is, maybe it is wrong, because in the support there will be no upward and so you can see ME. Okay, so ME, so you can use ME, the exceptional case, as we are using insert a internal hinge at the support, then it will be not upward, as we have been know. So rather than it will be go down, so it will be act like this. If we forcing down, act like this, and we know this is the support, that's why it will be 0. Okay, so this will be 0 and it will be upward, and it will be like this. As this is the support, this will be 0 and this will be 0. So this is the equation. Okay, so what will be this MC? MC will be act another way, which I've been showing you. If you calculate MC, then it will be not act this way or not act this way. Rather than it can use this way and this way, or 0. Well, not like that, never. Okay, we can see here another example. We can see MD. Here is a point D. This is the point of T. Sorry, it is point E. If we using internal hinge and using this way, so there will be no change. This is the point C, internal hinge. That's why it will be 0, and it is the hinge. This is the support. That's why it will be 0, and going this way and this way. Okay, let's see another example. Where is MR, MP? This is the point of P. So we are using internal hinge here, as we've been seeing the this is the fixed support. That's well, in the left segment will be not deflected, rather than right segment will be deflected. So as this is the support, that's why it will be 0, and this is the hinge, that's why it is go down in the hinge point, and this is also be 0, as we have been seeing this is the only one support. Then we are just drawing this way. How will calculate MR? This is the R. We are inserting a hinge here and pushing upward, so it will be like this. And another one, and this segment, this the total segment of this total segment, and it will be 0. So we are using this 0, and total segment is BF like this. So we are using MR, MQ. This is the Q. This is another exceptional case, as we've been seeing the left side is the fixed support. That's why it is acting like that. There will be no deflection. And another, if we using his there's then behavior like this. It will be go there, and this will be 0, as we know that this is the support. That's why we are taking this way. So that's why we are taking this way, as this will be must be 0. Okay. So another one, MC, we can see here MC. Where is MC? C. This is the support portion. If we want to draw the moment in the support, so as we know, the support will be never gone upward, so it will like this way and this way. So as there is a fixed support, no deflection is here, rather than this point is go down like that way. Okay, so another exceptional case is MA. So if we using internal hinge here, then what will be happen? The member will be act this way, as this is the support. That's why it will be must be 0. So will casing is 0 and go this way. So this way, and it will be casing 0 and go there. Okay, so let's see another example. Here that draw the moment influence line RARC, BB, BCL left, and B right, and BE, MB, MC, MEF. Okay. this must be last example. Okay, so you've been seeing here array, so we are taking is array, and this the support, that's why it will be 0, so we are taking this way, and is the internal hinge and this other. So there is a two support, as we know, if with a two support, then it will be like as a fixed support, so there is no doubt at all. This is the uh, this is the rules. Okay, so here is the RC. We've been seeing another example, the RC, the position of C you can see here. So one unit point is upward, and it will be 0, as we know, here the support, so this is 0, and his support is also upward, so this is going upward and this is also going. Okay, we've been seeing here another shear is at B, so this is the point of C. I will calculate, you are using the ruler support. So in the left side it will be going there, as we are pushing downward, and right side, so left side will be gone down, and right side it will be pushed upward, and it will be goes there, and this is the 0 we have been know, as the support is common here, that's why it is gone there, and it will also down, and we are melting here, because in this point we have been known the two support is here, that's why the behavior like switch support. Okay, BCL, we've been seeing here BCL this way, then if we use it will be behavior like this way, and BR, we can see here B left R this portion, so this is using this way. So BE, we can see BE here, BE portion, so it will be like that, this it will be like the MB. So if we use MB here, B portion, and just okay, so B portion MB, we are using internal hinge here, and it will be 0, as this is the support we have been known. That's why the left section and right section and gone there. Okay, and we know MC, here is the MC as the support, and at the support, that's why it is exceptional, that's why it will be go down and act like this, and ME, we have been seeing ME here, it will be like this way, Okay, we've been seeing here completed this, and now we are seeing finding RB, RC, and B, shear B left, and moment MC. You can see here RB, this is the RB, we're putting a 1 1, and B will like this will be 0, as this is the support. Okay, BL, which is left side, so you've been seeing here left. If we calculate here, as there the two support is left side, that will be acting as a fixed support. So BBL we can use here. BCR we can use the cutting is here, so this portion, I'm just using this portion, so if we go down, then it will be act like this way, that's why we are calculating this way, so we are erasing this one as is not needed, and the right portion will be upward, so it will be like this way and acting like this way. So we are using this and acting this way, but we are using this also, this portion, for our aesthetic. And BCR, we've been seeing at the point BCR, the right portion, where we're also doing this way. And MB, we've been seeing MB, there is MB, we're using internal hinge, as there is a already support, that's why it will be not upward or downward, rather than if we use internal hinge, then it will be go down. And MC, it will insert MC in internal hinge here, then what will be happen, the portion is will be upward, then it will be act like, and another is act like this way. Okay, this way and this way. You can see another example. This is the last example in our class. RA, we have been seeing RA, so we're putting is R1 and going there. And RE, we have been upward one unit weight and going here and to the 0 as the support is 0. And VV is we are using inserting a ruler support and going left side is down, right side is upward. And BCL, L means left, so we are cutting here. So if you cutting the left portion will be go there and right portion there will be no change as the fixed support. And BCR, if you cutting here, then what will be happen? The portion will be gone there and right certain will be not change. Okay. Okay, so it will be not acting like that as this is the sequence. That's why it will be go down this portion and it will be like this. This is exceptional. Okay, so MB within as in the MB if we use the internal hinge at the point of here, then what will be happen? It will be go down and it will be go down, and this is the MB. And ME, how will calculate the ME? Here is the ME. So it will be an exceptional as it is formed in the support. So if you support in hinge, then it will be not upward. Rather than if the force is applied in this member, then member will be go down deflected in this way, and going to the 0 and the support is here going to the, so in this way is going and support is going there. So I think the lecture also covered, we've been seeing here a reaction, shear, moment and influence line of the beam, Müller-Breslau. So if you have any question, then let me know. I'm trying to answer your question. Here is finding maximum moment. Okay, here is another formula. So okay, so we'll see the how we'll calculate the maximum moment and in the next lecture, not today, or somewhere. Okay, there is a examples we have been drawn. If you have any question, then let me know. Thank you everyone for your patience. Thank you.